All right. Hey guys, this is Mrs. Lyons, and I am going to work through the chemical reactions practice test for you. So let's take a look at this equation. So reactants. The reactants are always the things on the left side of the arrow. So in this case, AlBr3 and K2SO4. So that would be A. What is the 6? In front of KBr. The big numbers out front are coefficients. The 3 in AlBr3, the little number is a subscript. What does AQ represent? AQ means aqueous, which is dissolved in water. Which of the following is the correct set of integer coefficients for the balanced equation? So let me grab a piece of paper and let's balance this. Okay, so if we look at this equation, we have carbon, oxygen, and hydrogen. And I put those in a really weird order. And notice this is the reverse of a combustion reaction. Okay, this is what happens in plants when they are doing photosynthesis. So we have 1 carbon, 3 oxygen, and 2 hydrogen. On the product side, the right side, I have 6 carbon, 12 hydrogen, and 6, 7, 8 oxygen. Okay, so the first thing I'm going to do is I'm going to balance my carbon by putting a 6 over here. All right, so that gives me 6 carbon. I'm going to worry about my oxygen once I get carbon and hydrogen figured out. Here I have 12 hydrogen. Here I have 2. So if I put a 6 out here, that gives me 6 times 2 is 12 hydrogen. Okay. So now my carbon is balanced, my hydrogen is balanced. Let's count up my oxygen. So 6 times 2 is 12 oxygen plus 6 is a total of 18 oxygen. If you look right here, we have 6 oxygen in our C6H12O6. So if we 18 minus 6 is 12, so that means this is going to have to be a 6. Okay, so 6 times 2 is 12 plus 6 gives me 18 oxygen. And over here we said we have, oops, that's hydrogen, 18 oxygen. Okay, so 6, 6, 1, 6 are my coefficients. Okay, here's another one. All right. I don't know if you can hear my puppies, but they're playing in the background, making a ruckus. They don't know that we've got serious testing business going on here. All right. So another combustion reaction. Okay. Now, I'm gonna write this correctly this time. CHO. Here I have 2 carbon, 6 hydrogen, 2 oxygen, 1 carbon, 2 hydrogen, 3 oxygen. Now, what I recommend in a normal combustion reaction, okay, when you just have a hydrocarbon, look at the hydrogen first. In this case, I have 6 hydrogen, which means I would have to put a coefficient of 3 here. Okay, 3 times 2 gives me 6. However, that would give me an uneven number of oxygen. So instead of putting a 3 here, I'm just going to straight up double that. I'm going to make that 6. Okay, so that gives me 12 hydrogen, which means over here I need a 2. 2 times 6 is 12. Now I have 2 times 2 is 4 carbon, okay? Which means over here I need to put a 4. Okay, so 4. So now I've got 4 carbon, 12 hydrogen. Let's count up. I've got 4 times 2 is 8 plus 6. So I have a total of 14 oxygen here, which means I need a 7. 7 times 2 is 14. So now I have 14 oxygen on each side. All right. I think the combustion reactions are by far the hardest ones to balance. All right, so number 7. When solid carbon burns in a limited supply of oxygen gas, the gas, carbon, so let's underline something. Carbon, oxygen gas, the gas carbon monoxide forms. Okay, then it gives us a whole bunch of nonsense, not nonsense, but extra information. This gas is deadly to humans because when it combines with hemoglobin, makes it impossible to transport oxygen. But we don't really care. We don't need to know about that. All right. What it does say is write a balanced equation for the formation of carbon monoxide. So we know that our product is going to be carbon monoxide. Okay. And it tells us that it's a gas. Okay. So that's our product. It tells us also that we have solid carbon. Okay. Carbon is not one of the Haber-Finkel 7, the 7 diatomic elements. And it burns in oxygen gas. Okay, so carbon plus oxygen. Oxygen is one of the 7 diatomics. So we have a 2 here, and it's a gas. So gas. All right, so then if we need to balance that, if I look, here I have 2 oxygen. So if I put a 2 here, and I have 2 oxygen, I also have 2 carbon. So let's see if this is one of our options. 2 solid carbon plus 1 molecule of oxygen gas provides 2 gaseous carbon monoxide. So that means C is our correct answer. Oh shoot, I didn't circle the answers up here. 6616, so that should be D, and 2746, D. Okay. All right. Which of the following are soluble in water? Uh-oh, did I bring my solubility chart? That's possibly problematic. All right. So if you have your solubility chart, what you will see is that chloride, bromide, and iodide, when they are combined with silver, are insoluble. The thing that you'll also see if you look on that solubility chart for nitrate, all nitrates are soluble. So silver nitrate is going to be soluble in water. And then which of the following is soluble in water? These are all sulfides. Okay. If you look at your solubility rules, all sulfides are insoluble except the sulfides of group 1 metals, which potassium is a group 1 metal, which means that potassium would be water soluble. All right. All right, so we're taking word equations and writing chemical equations. All right. When a piece of aluminum metal is dropped into hydrochloric acid, hydrogen is released as a gas and a solution of aluminum chloride forms. Okay, so aluminum metal, okay, that's just going to be AlS, solid, plus hydrochloric acid, and I give you the formula for hydrochloric acid, which is HCl. It doesn't tell you, but that would be aqueous. If I don't tell you, ask me and I will tell you, okay? And then it tells us when this is done, hydrogen is released as a gas. So hydrogen is one of the 7 diatomic elements, so that's going to be H2 as a gas. And a solution, okay, when we see the word solution, that means aqueous. So a solution of aluminum chloride. Aluminum has a +3 charge, chlorine has a -1, so we end up with AlCl3. It's a solution, so that is aqueous. Okay. And let's see, we do want a balanced chemical equation. So let's see, I have 2 hydrogen and only 1 hydrogen, and I have 3 chlorine and only 1 chlorine. Okay, so if I balance here first, if I put a 3 here, okay, that gives me 3 chlorine. Okay, however, it gives me 3 hydrogen. So I've still got to come up with that least common multiple of 3 and 2. So if I put a 3 here, I've got 6 hydrogen. If I put a 6 here, I've got 6 HCl. So now if I put a 2 here, I've got 2 times 3 is 6. I've got 6. 6 hydrogen. Last little bit is I've got 2 aluminum, so I put a 2 there. All right. Okay. In the industrial preparation of chlorine, an electric current is passed through an aqueous solution of sodium chloride to give chlorine and hydrogen gases. The other product of this reaction is sodium hydroxide. Okay, so it's telling us we have a solution of water. So we're going to start out chlorine. Let's see. This is telling us to prepare chlorine. Okay, so chlorine is one of our products. Okay, an electric current is passed through an aqueous solution of sodium chloride. So sodium chloride is NaCl, AQ for aqueous. All right. And in this reaction, okay, I'm gonna wait a minute and I'll explain to you something. It tells us to give chlorine and hydrogen gases. So we've got chlorine gas. We've also got, oh my goodness, I'm sorry guys, my dogs are going crazy. Hydrogen gas, okay? So it's saying it produces hydrogen and chlorine. And the other product is sodium hydroxide, which would be NaOH, okay? All right, now, here's the thing. If we look, sodium chloride does not have any hydrogen in it, or oxygen for that matter. So when it says it's an aqueous solution, what we have to assume is that we have water, okay? And water is a liquid. And I wrote it HOH, which you may remember because I've got H2 and I've got hydroxide. Okay, so if I look at this, I've got 2 hydrogen, 2 chlorine. So let's do this. If I go 2 here, now I have 2 chlorine. I've got 2 sodium, so I'm going to put a 2 here. Now I have 2 hydroxide. So if I put a 2 here, I believe I have 2 hydrogen, 2 hydrogen, 2 hydroxide, 2 hydroxide, 2 sodium, 2 sodium, and 2 chlorine. So my equation is now balanced. All right. I will not give you one like that on the test. Okay. That was very involved. It's really not either one of the types of any of the types of reactions that we have done. All right. Balancing. So I'm going to kind of go through some of these. I know by now some of you can probably look at this and balance it, but I want to kind of give you the visual way of looking at this. Okay, so if I look at this, I've got 2 hydrogen and 2 iodine. I'm going to write that. I've got hydrogen and I've got iodine. On the left side, I have 2 hydrogen, 2 iodine. On the right side, I have 1 hydrogen and 1 hydrogen. 1 hydrogen and 1 iodine. So this one's pretty straightforward because all I really have to do is put a 2 here, and that gives me 2 hydrogen, 2 iodine. So that one was pretty easy peasy. Whoops. So then I put a 1 in each of those. If you don't put a 1, it won't count against you. Okay, so let's look at this one. All right, we have aluminum plus oxygen produces aluminum oxide. So let's make a list of our elements. So I have 1 aluminum. Actually, you know what? I'm going to do this the other way. All right, I'm going to draw these. So if you look here, okay, I have 1 aluminum and 2 oxygen. Over here, I have 3 oxygen. Okay, so I'm going to start with oxygen. I know I've got 3 here and 2 here, so I need at least 1 more of these. Okay, now I have 4 oxygen. Here I have 3, so I need more oxygen over here. So I'm going to make another Al2O3. Now I've got 6 oxygen. Here I've got 4. So if I put a third one, so I've got 2, 4, 6 oxygen, 3, 6 oxygen. And now I have 2 plus 2, I have 4 aluminum. So aluminum, that's 1. 2, 3, 4. So if you do this way, I count 1, 2, 3, 4 aluminum, 1, 2, 3 O2, and 1, 2 Al2O3. Okay, so those are my coefficients. All right. Let's do the same thing with this one. Just because I know that like I said, some of you have got this down. Some of you are still struggling, and I feel like the most visual way to do this is to kind of list it out like that. All right, so if I look here, I have aluminum plus HBr produces aluminum bromide plus hydrogen. So if I look right off the bat, I have 3 bromine here. I only have 1 over here. So I'm going to add 2 more HBr. Okay, so now I've got 3. I've got 3. If I look at this though, here's a problem. I have 3 hydrogen here. I only have 2 hydrogen here. Okay, so we got to have the least common multiple. So we got to work up to 6 hydrogen. Okay, so here I've got 2. If I add a second, that gives me 4. If I add a third, H2, now I have 2, 4, 6 hydrogen. Here I have 1, 2, 3, 4, 5, 6. All right. Now let's see what I've got. So I've got 2, 4, 6 hydrogen. 1, 2, 3, 4, 5, 6 hydrogen. All right. I have 1, 2, 3, 4, 5, 6 bromine, which means I need another AlBr3. So now I've got 3 plus 3 is 6 bromine. I've got 2 aluminum. So I need to add 1 more aluminum. Okay. So now I've got 2 aluminum, 2 aluminum. 1, 2, 3, 4, 5, 6 hydrogen, 2, 4, 6 hydrogen. And then I've got 1, 2, 3, 4, 5, 6 bromine, and 3 plus 3 is 6 bromine. So my coefficients, I have 2 aluminum, 6 HBr, 2 AlBr3, and 3 hydrogen. Okay. All right. Let's see. Can we do this one just by inspection? Meaning, can you look at this and see that I have 5 oxygen here and 2 oxygen here? What's the least common multiple of 2 and 5? In other words, what's the smallest number 2 and 5 both go into? To come up with 10. Okay, so that is the least common multiple. So in order to give me 10 oxygen here, I would need 5 O2 molecules. 5 times 2 is 10. In order to give me 10 oxygen atoms over here, I would need 2 P2O5 molecules. 2 times 5 is 10. Okay. Now, I've got 2 times 2 is 4 phosphorus. So over here, I put a 4 phosphorus and my chemical reaction is balanced. Ooh, another one of these. Okay, so I'm just gonna kind of walk you through this just by inspection, okay? Always do hydrogen first. So if I look here, I have 14 hydrogen, right? Over here, I have 2. So I would need a 7 here, okay? However, 7 is an odd number, okay? Remember, when we get an odd number of water, our equation's never going to balance. So what I suggest to do, and I know I said in the past you could do like 3.5 or, put a 0.5. Actually, if you do this and you just double this, so if I, instead of 7, I say I have 14, okay? Now I have 14 times 2 is 28 hydrogen. So I go over here, I can put a 2. 2 times 14 is 28. 2 times 6 is 12 carbon. So I would need 12 carbon here. Okay. Now let's count up my oxygen. I have 12 times 2, so that's 24. And then I have 14. So I have a total of 38 oxygen. Half of that is 19. So 2, 19, 12, 14 are our coefficients for that reaction. Okay, so we need to look at single replacement reactions. Oh, good. I left without an activity series, but I have one. All right, so for single replacement reactions, remember we use our activity series. And what we said is the element at the top of the activity series is the most reactive. I don't know if I told every class this, but I use the example of Riz. Okay, I know that's a word from last year that means popularity. You've got Riz, means you've got style. Okay, lithium is our element with the most style. Lithium is the element that is always going to end up as part of a compound. Okay, if it's an option, lithium will be part of a compound. It will not just be by itself. And then as we go down the table, the elements get less reactive. Okay, so when we look at a single replacement reaction, okay, and remember we talked about water. Instead of writing it as H2O, we said write it as hydrogen hydroxide. Okay, so what we're going to do is we're going to compare sodium with hydrogen on our list. Okay, so sodium is here. Hydrogen is all the way down here. So sodium is going to end up in the compound. Okay, so what that means is sodium is going to take this first hydrogen's place. Excuse me. So we end up with NaOH. All right. We've got to look at charges. Okay, sodium is +1. The hydroxide ion is -1. So this is just NaOH. Okay, and then hydrogen, the first hydrogen gets kicked out. So we end up with hydrogen. Now, hydrogen is one of the Hoberfinkel 7. It's one of our 7 diatomic elements. So it turns out it's going to be H2. All right, now we do want to put states of matter in here. So here we've got sodium's a solid, water's a liquid. Remember, in single replacement reactions, the compounds are always going to be aqueous, and hydrogen by itself, when it's elemental hydrogen, is a gas. All right. If I wanted to balance this, I have 2 hydrogens, which means I need a 2 here. Okay, that gives me 2 hydroxides, which means I need a 2 here. That gives me 2 sodiums, which means I need a 2 there. And then my equation is balanced. All right, number 14, we have chlorine and NaF. So our element by itself is chlorine. Now, notice we have a very short list down here: fluorine, chlorine, bromine, iodine. Okay, those elements can only be compared to each other. All right, so we have chlorine and fluorine. All right, fluorine is higher on the activity series. That means fluorine is going to end up in the compound. Well, check it out. Fluorine is already in the compound, which means chlorine can't replace it. So this is a NR, no reaction. All right. Last one, we have lithium and we have calcium nitrate. So we need to compare lithium and calcium in our activity series. Oh yeah, lithium is all the way up here at the top. So lithium is going to end up in the compound. Calcium is going to end up by itself. All right, which means lithium is going to take calcium's place. So we're going to end up with LiNO3 plus Ca. Now, we can't just leave it at that. We got to do a little bit of thinking about it. Okay, lithium on the periodic table forms +1 ions. Nitrate, if you look at the back of your periodic table, is forms -1 ions. Okay, so in this case, lithium nitrate is just LiNO3 AQ. Calcium, when it's by itself, it's not part of the 7 diatomic, so it doesn't get a subscript, and it is a solid. Okay, so that is that single replacement reaction. We need to balance it because we've got 2 nitrates on the left, only 1 on the right. So if I put a 2 here, now I have 2 NO3s. I also have 2 lithiums, which is easy enough. I put a 2 there. My equation is balanced. All right, on to the double replacement reactions. Okay, now remember what we said. We said that the anions are going to switch places. So in this case, we're going to end up with magnesium and fluorine and lithium and chlorine. Okay, whenever we're forming a compound, we have to look at charges. Okay, so magnesium has a +2 charge, fluorine has a -1. So our formula ends up being MgF2. Lithium has a +1 charge, chlorine has a -1 charge. So we end up just with LiCl. Okay, now what we have to do before we do anything else is we have to look at our solubility rules. Okay, and I left my solubility rules at school, but if you look, lithium is a group 1 metal, chloride is listed in the solubility table. This compound is going to be soluble because all group 1 metals are make soluble compounds. So this is going to be AQ. All right. If you look at fluorine, however, the fluoride ion, when it's combined with magnesium, is insoluble. So that is going to be forming our solid. Okay. So let's see. We are not quite balanced. To balance, we need a 2 here and a 2 here. Okay, so now we need to write the net ionic equation. So what we're going to do for the net ionic equation for all aqueous compounds, we're going to break the compound into its ions. Okay, so for example, magnesium and chlorine, we're going to have magnesium that has a +2 charge. And this is Cl2. Oh, we should put aqueous behind that. AQ. Plus Cl, it's Cl2, so we need to put that 2 out front because we have 2 chloride ions. 2 Cl minus AQ. And then lithium fluoride, there's a 2, so we have 2 lithium plus 1 AQ plus 2 fluorine AQ. Okay, lithium's +1, fluorine's -1. So those are our reactants. Our products are MgF2, which is a solid. So MgF2, that stays together, plus 2 lithium ions, plus 2 chloride ions. All right, so the whole purpose of a net ionic equation is to cross out the things that exist on both sides of the equation. Okay, these are called our spectator ions. So if we look, I have 2 chlorine ions on both sides. So I'm going to cross that off and I'm going to cross that off. All right. I also have 2 lithium ions on both sides. 2 on each side. So I'm going to cross those off. All right. And that leaves me with this Mg plus 2 plus 2 fluoride ions react and form a precipitate of MgF2 solid. Okay, so that is our net ionic equation. Okay, all right, one more. Now, again, we're going to combine we're going to switch anions. So we're going to have NaNO3 plus BaCl. All right. Sodium is +1. Nitrate is -1. So this does just end up being NaNO3. Barium is +2. Chloride is -1. So this ends up being BaCl2. All right. So now we need to look at our solubility rules. Sodium is a group 1 metal. So we already know that all group 1 metals are soluble. So that's aqueous. And then we have barium chloride, chlorine. Okay, chlorides are all soluble except for those few, silver, mercury, and lead. Oh my goodness. Do you hear my puppies? Someone is outside walking. I apologize. So this is aqueous also. So when this happens, we don't have to do any more. We don't have to balance it. We don't have to do anything. We can just write in our no reaction. All right. So that was a very quick run through, but a run through nonetheless of the practice test. If you are good with this, the only thing, and we mentioned this in my fourth period class, identifying the types of reactions. So let's make sure that you know the 5 types. So we have synthesis, decomposition, combustion. Hear those silly puppies. They're going crazy. They want to go outside and chase whoever's out there. Oh my goodness. Drive me crazy. All right, so these are the 5 types of reactions. Synthesis. Synthesis is going to look like this. A plus B, 2 elements combine to give us a compound. Decomposition is the opposite. Something's decomposing. So we have one compound. It breaks apart into smaller things. Combustion is the one, and I said, go look for combustion first. Combustion's the one that has a hydrogen, carbon, hydrogen compound plus oxygen. Okay. It's going to produce CO2 plus H2O. Okay. Single replacement is when we have a compound plus an element. Okay. And we end up with a compound plus an element. One element replaces another. And then finally, in double replacement, we have 2 compounds to start with, and we have 2 compounds as products. Okay. All right. I will see you in class. Have a great night and take care.